Section 9 of My Inventions and Other Works of Nikola Tesla, Electrical Experimenter, February to October 1919. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Lawrence Trask, Mount Vernon, Ohio, interfaceaudio.com. Tesla on High-Frequency Generators by Nikola Tesla. This article was published in Electrical Experimenter, April 1919. Editor, Electrical Experimenter. It is to be regretted that a letter addressed to me by Mr. J. Harris Rogers, in your care, was published in the March number of the Electrical Experimenter. Although the concurrence of our views in some wireless features might have made this desirable to so wide-awake and enterprising a periodical as yours. Mr. Rogers seems to be a very appreciative gentleman, and nothing would be farther from my thoughts than to detract anything from his merit. But in a separate contribution which I expect to prepare for your next issue, I shall express myself on this subject without prejudice and in the interest of truth. However, the article by your Mr. H. Winfield Secor on America's Greatest War Invention, the Rogers Underground Wireless, contains a reference to a novel and original high-frequency generator of Mr. Rogers' invention. May I not, to use the President's elegant expression, call attention to the fact that this device was described by me years ago, as will be evident from the following excerpt of a communication which appeared in the Electrical Review of March 15, 1899. In speaking of circuit controllers, I said, "I may mention here, based on a different principle, which is incomparably more effective, more efficient, and also simpler on the whole. It comprises a fine stream of conducting fluid, which is made to issue, with any desired speed, from an orifice connected with one pole of a generator, through the primary of the induction coil, against the other terminal of the generator placed at a small distance. This device gives discharges of remarkable suddenness, and the frequency may be brought within reasonable limits, almost to anything desired. I have used this device for a long time in connection with ordinary coils, and in a form of my own coil, with results greatly superior in every respect to those obtainable with the form of your letter. Make a few statements referring to such make-and-break devices in general, and various forms based on this new principle. I may add that a great many forms of this apparatus were constructed and employed by me for a long time, proving very convenient and useful. Water does not give particularly good results, being incapable of causing very abrupt changes, but electrolytes have the property of diminishing enormously in resistance when they are heated, and the effects are much more intense. Salts of lithium are especially efficient. Nikola Tesla, New York, February 20th, 1919. End of Section 9. Recording by Lawrence Trask, Mount Vernon, Ohio, interfaceaudio.com. Section 10 of My Inventions and Other Works of Nikola Tesla, Electrical Experimenter, February to October 1919. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Lawrence Trask, Mount Vernon, Ohio, interfaceaudio.com. The True Wireless by Nikola Tesla. This article was published in Electrical Experimenter, May 1919. Ever since the announcement of Maxwell's electromagnetic theory, scientific investigators all the world over had been bent on its experimental verification. They were convinced that it would be done, and lived in an atmosphere of eager expectancy, unusually favorable to the reception of any evidence to this end. No wonder, then, that the publication of Dr. Heinrich Hertz's results caused a thrill as had scarcely ever been experienced before. At that time I was in the midst of pressing work in connection with the commercial introduction of my system of power transmission, but nevertheless caught the fire of enthusiasm, and fairly burned with desire to behold the miracle with my own eyes. Accordingly, as soon as I had freed myself of these imperative duties and resumed research work in my laboratory on Grand Street, New York, I began, parallel with high frequency alternators, the construction of several forms of apparatus, with the object of exploring the field opened up by Dr. Hertz. Recognizing the limitations of the devices he had employed, I concentrated my attention on the production of a powerful induction coil, but made no notable progress until a happy inspiration led me to the invention of the oscillation transformer. In the latter part of 1891, I was already so far advanced in the development of this new principle that I had at my disposal means vastly superior to those of the German physicist. All my previous efforts with Ruhmkorff coils had left me unconvinced, and in order to settle my doubts, I went over the whole ground once more, very carefully, with these improved appliances. Similar phenomena were noted, greatly magnified in intensity, but they were susceptible of a different and more plausible explanation. I considered this so important that in 1892 I went to Bonn, Germany, to confer with Dr. Hertz in regard to my observations. He seemed disappointed to such a degree that I regretted my trip, and parted from him sorrowfully. During the succeeding years I made numerous experiments with the same object, but the results were uniformly negative. In 1900, however, after I had evolved a wireless transmitter which enabled me to obtain electromagnetic activities of many millions of horsepower, I made a last desperate attempt to prove that the disturbances emanating from the oscillator were either vibrations akin to those of light, but met again with utter failure. For more than 18 years I have been reading treatises, reports of scientific transactions, and articles on Hertz wave telegraphy to keep myself informed, but they always impressed me like works of fiction. The history of science shows that theories are perishable. With every new truth that is revealed, we get a better understanding of nature, and our conceptions and views are modified. Dr. Hertz did not discover a new principle. He merely gave material support to a hypothesis which had been long ago formulated. It was a perfectly well established fact that a circuit, traversed by a periodic current, emitted some kind of space waves, but we were in ignorance as to their character. He apparently gave an experimental proof that they were transversal vibrations in the ether. Most people look upon this as his great accomplishment. To my mind it seems that his immortal merit was not so much in this as in the focusing of the investigator's attention on the processes taking place in the ambient medium. The Hertz wave theory, by its fascinating hold on the imagination, has stifled creative effort in the wireless art and retarded it for 25 years. But on the other hand, it is impossible to overestimate the beneficial effects of the powerful stimulus it has given in many directions. As regards signaling without wires, the application of these radiations for the purpose was quite obvious. When Dr. Hertz was asked whether such a system would be of practical value, he did not think so, and he was correct in his forecast. The best that might have been expected was a method of communication similar to the heliographic, and subject to the same or even greater limitations. In the spring of 1891, I gave my demonstrations with a high-frequency machine before the American Institute of Electrical Engineers at Columbia College, which laid the foundation to a new and far more promising departure. Although the laws of electrical resonance were well known at that time, and my lamented friend Dr. John Hopkinson had even indicated their specific application to an alternator in the Proceedings of the Institute of Electrical Engineers, London, November 13, 1889, nothing had been done toward the practical use of this knowledge, and it is probable that those experiments of mine were the first published exhibition with resonant circuits, more particularly of a high frequency. While the spontaneous success of my lecture was due to spectacular features, its chief import was in showing that all kinds of devices could be operated through a single wire without return. This was the initial step in the evolution of my wireless system. The idea presented itself to me that it might be possible, under observance of proper conditions of resonance, to transmit electric energy through the earth, thus dispensing with all artificial conductors. Anyone who might wish to examine impartially the merit of that early suggestion must not view it in the light of present-day science. I only need to say that as late as 1893, when I had prepared an elaborate chapter on my wireless system, dwelling on its various instrumentalities and future prospects, Mr. Joseph Wetzler and other friends of mine emphatically protested against its publication, on the ground that such idle and far-fetched speculations would injure me in the opinion of conservative business men. So it came that only a small part of what I intended to say was embodied in my address of that year before the Franklin Institute and National Electric Light Association, under the chapter on Electrical Resonance. This little salvage from the wreck has earned me the title of Father of the Wireless from many well-disposed fellow workers, rather than the invention of scores of appliances that have brought wireless transmission within the reach of every young amateur, and which, in a time not distant, will lead to undertakings overshadowing, in magnitude and importance, all past achievements of the engineer. The popular impression is that my wireless work was begun in 1893, but as a matter of fact I spent the 2 preceding years in investigations, employing forms of apparatus, some of which were almost like those of today. It was clear to me from the very start that the successful consummation could only be brought about by a number of radical improvements. Suitable high-frequency generators and electrical oscillators had first to be produced. The energy of these had to be transformed in effective transmitters and collected at a distance in proper receivers. Such a system would be manifestly circumscribed in its usefulness if all extraneous interference were not prevented and exclusiveness secured. In time, however, I recognized that devices of this kind, to be most effective and efficient, should be designed with due regard to the physical properties of this planet and the electrical conditions obtaining on the same. I will briefly touch upon the salient advances as they were made in the gradual development of the system. The high-frequency alternator employed in my first demonstrations is illustrated in Figure 1. It comprised a field ring with 384 pole projections and a disc armature with coils wound in one single layer, which were connected in various ways according to requirements. It was an excellent machine for experimental purposes, furnishing sinusoidal currents of from 10,000 to 20,000 cycles per second. The output was comparatively large, due to the fact that as much as 30 amperes per square millimeter could be passed through the coils without injury. The diagram in Figure 2 shows the circuit arrangements as used in my lecture. Resonant conditions were maintained by means of a condenser subdivided into small sections, the finer adjustments being effected by a movable iron core within an inductance coil. Loosely linked with the latter was a high-tension secondary, which was tuned to the primary. The operation of devices through a single wire, without return, was puzzling at first because of its novelty, but can be readily explained by suitable analogues. For this purpose, reference is made to figures 3 and 4. In the former, the low-resistance electric conductors are represented by pipes of large section, the alternator by an oscillating piston, and the filament of an incandescent lamp by a minute channel connecting the pipes. It will be clear from a glance at the diagram that very slight excursions of the piston would cause the fluid to rush with high velocity through the small channel, and that virtually all the energy movement would be transformed into heat by friction, similarly to that of the electric current in the lamp filament. The second diagram will now be self-explanatory. Corresponding to the terminal capacity of the electric system, an elastic reservoir is employed which dispenses with the necessity of a return pipe. As the piston oscillates, the bag expands and contracts, and the fluid is made to surge through the restricted passage with great speed, this resulting in the generation of heat as in the incandescent lamp. Theoretically considered, the efficiency of conversion of energy should be the same in both cases. Granted, then, that an economic system of power transmission through a single wire is practicable, the question arises how to collect the energy in the receivers. With this object, attention is called to Figure 5, in which a conductor is shown excited by an oscillator joined to it at one end. Evidently, as the periodic impulses pass through the wire, differences of potential will be created along the same, as well as at right angles to it in the surrounding medium, and either of these may be usefully applied. Thus, at A, a circuit comprising an inductance and capacity is resonantly excited in the transverse, and at B, in the longitudinal sense, at C, energy is collected in a circuit parallel to the conductor, but not in contact with it, and again at D, in a circuit which is partly sunk into the conductor, and may be or not electrically connected to the same. It is important to keep these typical dispositions in mind, for however the distant actions of the oscillator might be modified through the immense extent of the globe, the principles involved are the same. Consider now the effect of such a conductor of vast dimensions on a circuit exciting it. The upper diagram of Figure 6 illustrates a familiar oscillating system comprising a straight rod of self-inductance 2L, with small terminal capacities Cc and a node in the center. In the lower diagram of the figure, a large capacity C is attached to the rod at one end, with the result of shifting the node to the right through a distance corresponding to self-inductance X. As both parts of the system on either side of the node vibrate at the same rate, we have evidently L plus X, C equals L minus X, C, from which X equals L, C minus C divided by C plus C. When the capacity C becomes commensurate to that of the Earth, X approximates L. In other words, the node is close to the ground connection. The exact determination of its position is very important in the calculation of certain terrestrial electrical and geodetic data, and I have devised special means with this purpose in view. My original plan of transmitting energy without wires is shown in the upper diagram of Figure 7, while the lower one illustrates its mechanical analog, first published in my article in the Century magazine of June, 1900. An alternator, preferably of high tension, has one of its terminals connected to the ground and the other to an elevated capacity, and impresses its oscillations upon the earth. At a distant point, a receiving circuit, likewise connected to ground and to an elevated capacity, collects some of the energy and actuates a suitable device. I suggested a multiplication of such units in order to intensify the effects, an idea which may yet prove valuable. In the analog, two tuning forks are provided, one at the sending and the other at the receiving station, each having attached to its lower prong a piston fitting in a cylinder. The two cylinders communicate with a large elastic reservoir filled with an incompressible fluid. The vibrations transmitted to either of the tuning forks excite them by resonance and through electrical contacts, or otherwise bring about the desired result. This, I may say, was not a mere mechanical illustration, but a simple representation of my apparatus for submarine signaling, perfected by me in 1892, but not appreciated at the time, although more efficient than the instruments now in use. The electric diagram in Figure 7, which was reproduced from my lecture, was meant only for the exposition of the principle. The arrangement, as I described it in detail, is shown in Figure 8. In this case, an alternator energizes the primary of a transformer, the high-tension secondary of which is connected to the ground, and an elevated capacity and tuned to the impressed oscillations. The receiving circuit consists of inductance connected to the ground and to an elevated terminal without break, and is resonantly responsive to the transmitted oscillations. A specific form of receiving device was not mentioned, but I had in mind to transform the received currents and thus make their volume and tension suitable for any purpose. This, in substance, is the system of today, and I am not aware of a single authenticated instance of successful transmission at considerable distance by different instrumentalities. It might perhaps not be clear to those who have perused my first description of these improvements that, besides making known new and efficient types of apparatus, I gave to the world a wireless system of potentialities far beyond anything before conceived. I made explicit and repeated statements that I contemplated transmission absolutely unlimited as to terrestrial distance and amount of energy. But although I have overcome all obstacles which seemed in the beginning unsurmountable, and found elegant solutions of all the problems which confronted me, yet even at this very day the majority of experts are still blind to the possibilities which are within easy attainment. My confidence that a signal could be easily flashed around the globe was strengthened through the discovery of the rotating brush, a wonderful phenomenon which I have fully described in my address before the Institution of Electrical Engineers, London, in 1892, and which is illustrated in Figure 9. This is undoubtedly the most delicate wireless detector known, but for a long time it was hard to produce and to maintain in the sensitive state. These difficulties do not exist now, and I am looking to valuable applications of this device, particularly in connection with the high-speed photographic method, which I suggested in wireless as well as in wire transmission. Possibly the most important advances during the following 3 or 4 years were my system of concatenated tuned circuits and methods of regulation, now universally adopted. The intimate bearing of these inventions on the development of the wireless art will appear from Figure 10, which illustrates an arrangement described in my U.S. Patent number 568178 of September 22, 1896, and corresponding dispositions of wireless apparatus. The captions of the individual diagrams are thought sufficiently explicit to dispense with further comment. I will merely remark that in this early record, in addition to indicating how any number of resonant circuits may be linked and regulated, I have shown the advantage of the proper timing of primary impulses and use of harmonics. In a farcical wireless suit in London, some engineers, reckless of their reputation, have claimed that my circuits were not at all attuned. In fact, they asserted that I had looked upon resonance as a sort of wild and untamable beast. It will be of interest to compare my system as first described to a Belgian patent of 1897 with the Hertz wave system of that period. The significant differences between them will be observed at a glance. The first enables us to transmit economically energy to any distance, and is of inestimable value. The latter is capable of a radius of only a few miles, and is worthless. In the first there are no spark gaps, and the actions are enormously magnified by resonance. In both transmitter and receiver the currents are transformed and rendered more effective and suitable for the operation of any desired device. Properly constructed, my system is safe against static and other interference, and the amount of energy which may be transmitted is billions of times greater than with the Hertzian, which has none of these virtues, has never been used successfully, and of which no trace can be found at the present. A well advertised expert gave out a statement in 1899 that my apparatus did not work, and that it would take 200 years before a message would be flashed across the Atlantic, and he even accepted stolidly my congratulations on a supposed great feat. But subsequent examination of the record showed that my devices were secretly used all the time, and ever since I learned of this, I have treated these Borgia Medici methods with the contempt in which they are held by all fair-minded men. The wholesale appropriation of my inventions was, however, not always without a diverting side. As an example to the point, I may mention my oscillation transformer, operating with an air gap. This was in turn replaced by a carbon arc, quenched gap, an atmosphere of hydrogen, argon, or helium, by a mechanical brake with oppositely rotating members, a mercury interrupter, or some kind of vacuum bulb, and by such tours de force as many new "systems" have been produced. I refer to this, of course, without the slightest ill feeling. Let us advance by all means. But I cannot help thinking how much better it would have been if the ingenious men who have originated these systems had invented something of their own, instead of depending on me altogether. Before 1900, two most valuable improvements were made. One of these was my individualized system with transmitters emitting a wave complex and receivers comprising separate tuned elements cooperatively associated. The underlying principle can be explained in a few words. Suppose that there are n simple vibrations suitable for use in wireless transmission. The probability that any one tune will be struck by an extraneous disturbance is 1 divided by n. There will then remain n-1 vibrations, and the chance that one of these will be excited is 1 divided by n-1. Hence the probability that 2 times would be struck at the same time is 1 divided by n times n-1. Similarly, for a combination of 3, the chance will be 1 divided by n times n-1 times n-2, and so on. It will readily be seen that in this manner any degree of safety against the statics or any kind of disturbance which can be attained, provided the receiving apparatus is so designed that its operation is possible only through the joint action of all the tuned element. This was a difficult problem which I have successfully solved, so that now any desired number of simultaneous messages is practicable in the transmission through the earth, as well as through artificial conductors. The other invention, of still greater importance, is a peculiar oscillator enabling the transmission of energy without wires, in any quantity that may ever be required for industrial use, to any distance, and with very high economy. It was the outcome of years of systematic study, and investigation, and wonders will be achieved by its means. The prevailing misconceptions of the mechanism involved in the wireless transmission has been responsible for various unwarranted announcements which have misled the public and worked harm. By keeping steadily in mind that the transmission through the earth is in every respect identical to that through a straight wire, one will gain a clear understanding of the phenomena, and will be able to judge correctly the merits of a new scheme. Without wishing to detract from the value of any plan that has been put forward, I may say that they are devoid of novelty. So, for instance, in Fig. 12, arrangements of transmitting and receiving circuits are illustrated. which I have described in my U.S. Patent number 613809 of November 8, 1898, on a method of and apparatus for controlling mechanism of moving vessels or vehicles, and which have been recently dished up as original discoveries. In other patents and technical publications, I have suggested conductors in the ground as one of the obvious modifications indicated in Figure 5. For the same reason, the statics are still the bane of the wireless. There is about as much virtue in the remedies recently proposed as in hair restorers. A small and compact apparatus has been produced which does away entirely with this trouble, at least in plants suitably remodeled. Nothing is more important in the present phase of development of the wireless art than to dispose of the dominant erroneous ideas. With this object I shall advance a few arguments based on my own observations, which prove that Hertz waves have little to do with the results obtained even at small distances. In Figure 13, a transmitter is shown radiating space waves of considerable frequency. It is generally believed that these waves pass along the earth's surface, and thus affect the receivers. I can hardly think of anything more improbable than this gliding wave theory, and the conception of the guided wireless, which are contrary to all laws of action and reaction. Why should these disturbances cling to a conductor, where they are counteracted by induced currents, when they can propagate in all other directions unimpeded? The fact is that the radiations of the transmitter passing along the earth's surface are soon extinguished. The height of the inactive zone indicated in the diagram being some function of the wavelength, the bulk of the waves traversing freely the atmosphere. The fact is that the radiations of the transmitter passing along the earth's surface are soon extinguished, the height of the inactive zone indicated in the diagram being some function of the wavelength, the bulk of the waves traversing freely the atmosphere. Terrestrial phenomena, which I have noted conclusively, show that there is no Heaviside layer, or if it exists, it is of no effect. It certainly would be unfortunate if the human race were thus imprisoned and forever without power to reach out into the depths of space. The actions at a distance cannot be proportionate to the height of the antenna and the current in the same. I shall endeavor to make this clear by reference to diagram in Figure 14. The elevated terminal charged to a high potential induces an equal and opposite charge in the earth, and there are thus Q lines giving an average current I equals 4 times Qn, which circulates locally and is useless except that it adds to the momentum. A relatively small number of lines, Q, however, go off to great distance, and to these corresponds a mean current of IE equals 4Qn, which is due to the action at a distance. The total average current in the antenna is thus I times M equals 4 times Qn plus 4 times Qn, and its intensity is no criterion for the performance. The electric efficiency of the antenna is Q divided by Q plus Q, and this is often a very small fraction. Dr. L. W. Austin and Mr. J. L. Hogan have made quantitative measurements which are valuable, but far from supporting the Hertz wave theory, they are evidences in disapproval of the same, as will be easily perceived by taking the above facts into consideration. Dr. Austin's researches are especially useful and instructive, and I regret that I cannot agree with him on this subject. I do not think that if his receiver was affected by Hertz waves, he could ever establish such relations as he has found, but he would be likely to reach these results if the Hertz waves were in a large part eliminated. At great distance the space waves and the current waves are of equal energy, the former being merely an accompanying manifestation of the latter in accordance with the fundamental teachings of Maxwell. At great distance the space waves and the current waves are of equal energy, the former being merely an accompanying manifestation of the latter, in accordance with the fundamental teachings of Maxwell. It occurs to me here to ask the question, why have the Hertz waves been reduced from the original frequencies to those I have advocated for my system, when in so doing the activity of the transmitting apparatus has been reduced a billionfold? I can invite any expert to perform an experiment such as illustrated in Figure 15, which shows the classical Hertz oscillator and my grounded transmitting circuit. It is a fact which I have demonstrated that although we may have in the Hertz oscillator an activity thousands of times greater, the effect on the receiver is not to be compared to that of the grounded circuit. This shows that in the transmission from an airplane we are merely working through a condenser, the capacity of which is a function of a logarithmic ratio between the length of the conductor and the distance from the ground. The receiver is affected in exactly the same manner as from an ordinary transmitter, the only difference being that there is a certain modification of the action which can be predetermined from the electrical constants. It is not at all difficult to maintain communication between an airplane and a station on the ground. On the contrary, the feat is very easy. To mention another experiment in support of my view, I may refer to Figure 16, in which two grounded circuits are shown excited by oscillations of the Hertzian order. It will be found that the antennas can be put out of parallelism without noticeable change in the action of the receiver, this proving that it is due to currents propagated through the ground, and not to space waves. Particularly significant are the results obtained in cases illustrated in Figures 17 and 18. In the former, an obstacle is shown in the path of the waves, but unless the receiver is within the effective electrostatic influence of the mountain range, the signals are not appreciably weakened by the presence of the latter, because the currents pass under it and excite the circuit in the same way, as if it were attached to an energized wire. If, as in Figure 18, a second range happens to be beyond the receiver, it could only strengthen the Hertz wave effect by reflection, but as a matter of fact it detracts greatly from the intensity of the received impulses, because the electric niveau between the mountains is raised, as I have explained in connection with my lightning protector in the Experimenter of February. Again, in Figure 19, two transmitting circuits, one grounded directly and the other through an air gap, are shown. It is a common observation that the former is far more effective, which could not be the case in a transmission with Hertz radiations. In like manner, if two grounded circuits are observed from day to day, the effect is found to increase greatly with the dampness of the ground, and the same reason also the transmission through sea water is more efficient. An illuminating experiment is indicated in Figure 20, in which two grounded transmitters are shown, one with a large and the other with a small terminal capacity. Suppose that the latter be 1/10 of the former, but that it is charged to 10 times the potential, and let the frequency of the two circuits, and therefore the currents in both antennas, be exactly the same. The circuit with the smaller capacity will then have 10 times the energy of the other, but the effects on the receiver will be in no wise proportionate. The same conclusions will be reached by transmitting and receiving circuits with wires buried underground. In each case the actions carefully investigated will be found due to earth currents. Numerous other proofs might be cited which can be easily verified. So, for example, oscillations of low frequency are ever so much more effective in the transmission which is inconsistent with the prevailing idea. My observations in 1900 and the recent transmissions of signals to very great distances are another emphatic disproval. The Hertz wave theory of wireless transmission may be kept up for a while, but I do not hesitate to say that in a short time it will be recognized as one of the most remarkable and inexplicable aberrations of the scientific mind which has ever been recorded in history. End of section 10. Recording by Lawrence Trask, Mount Vernon, Ohio. InterfaceAudio.com.
Section 11 of My Inventions and Other Works, Nikola Tesla, Electrical Experimenter, February to October 1919. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Tesla Bulbs, June 1919, by Nikola Tesla. This article was published in Electrical Experimenter, June 1919. In the May issue, in his article True Wireless, Nikola Tesla mentions the forerunner of the Audion, a vacuum bulb which he used in his earlier experiments. We have been in receipt of numerous letters from many individuals interested in this bulb who desire further particulars as to its operation, etc. Accordingly, we publish herewith some excerpts from a lecture by Dr. Tesla delivered before the Institution of Electrical Engineers and Royal Institution, London, February 1892. I think it best at this juncture to bring before you a phenomenon observed by me some time ago, which to the purely scientific investigator may perhaps appear more interesting than any of the results which I have the privilege to present to you this evening. It may be quite properly ranked among the brush phenomena. In fact, it is a brush formed at or near a single terminal in high vacuum. In bulbs provided with a conducting terminal, though it be of aluminum, the brush has but an ephemeral existence, and cannot, unfortunately, be indefinitely preserved in its most sensitive state, even in a bulb devoid of any conducting electrode. In studying the phenomenon, by all means, a bulb having no leading-in wire should be used. I have found it best to use bulbs constructed as indicated in Figures 1 and 2. In Figure 1, the bulb comprises an incandescent lamp globe L, in the neck of which is sealed a barometer tube B, the end of which is blown out to form a small sphere S. This sphere should be sealed as closely as possible in the center of the large globe. Before sealing, a thin tube T of aluminum sheet may be slipped into the barometer tube, but it is not important to employ it. The small hollow sphere S is filled with some conducting powder, and a wire W is cemented in the neck for the purpose of connecting the conducting powder with the generator. The construction shown in Figure 2 was chosen in order to remove from the brush any conducting body which might possibly affect it. The bulb consists in this case of a lamp globe L, which has a neck N, provided with a tube B and a small sphere S sealed to it, so that two entirely independent compartments are formed as indicated in the drawing. When the bulb is in use, the neck N is provided with a tinfoil coating, which is connected to the generator and acts inductively upon the moderately rarefied and highly conducting gas enclosed in the neck. From there, the current passes through the tube B into the small sphere S to act by induction upon the gas contained in the globe L. It is of advantage to make the tube T very thick, the hole through it very small, and to blow the sphere S very thin. It is of the greatest importance that the sphere S be placed in the center of the globe L. Figures 3, 4, and 5 indicate different forms or stages of the brush. Figure 1 shows the brush as it first appears in a bulb provided with a conducting terminal, but as in such a bulb it very soon disappears, often after a few minutes, I will confine myself to the description of the phenomenon as seen in a bulb without conducting electrode. It is observed under the following conditions. When the globe L, figures 1 and 2, is exhausted to a very high degree, generally the bulb is not excited upon connecting the wire W, figure 1, or the tinfoil coating of the bulb, figure 2, to the terminal of the induction coil. To excite it, it is usually sufficient to grasp the globe L with the hand. An intense phosphorescence then spreads at first over the globe, but soon gives place to a white, misty light. Shortly afterward, one may notice that the luminosity is unevenly distributed in the globe, and after passing the current for some time, the bulb appears as in Figure 4. From this stage, the phenomenon will gradually pass to that indicated in Figure 5, after some minutes, hours, days, or weeks, according as the bulb is worked. Warming the bulb or increasing the potential hastens the transit. When the brush assumes the form indicated in Figure 5, it may be brought to a state of extreme sensitiveness to electrostatic and magnetic influence. The bulb hanging straight down from a wire, and all objects being remote from it, the approach of the observer at a few paces from the bulb will cause the brush to fly to the opposite side, and if he walks around the bulb, it will always keep on the opposite side. It may begin to spin around the terminal long before it reaches the sensitive stage, when it begins to turn around principally, but also before it is affected by a magnet, and at a certain stage it is susceptible to magnetic influence to an astonishing degree. A small permanent magnet, with its poles at a distance of no more than 2 centimeters, will affect it visibly at a distance of 2 meters, slowing down or accelerating the rotation according to how it is held relatively to the brush. I think I have observed that at the stage when it is most sensitive to magnetic, it is not most sensitive to electrostatic influence. When the bulb hangs with the globe L down, the rotation is always clockwise. In the southern hemisphere, it would occur in the opposite direction, and on the equator, the brush should not turn at all. The rotation may be reversed by a magnet kept at some distance. The brush rotates best, seemingly, when it is at right angles to the lines of force of the earth. It very likely rotates, when at its maximum speed, in synchronism with the alternations, say 10,000 times a second. The rotation can be slowed down or accelerated by the approach or receding of the observer, or any conducting body, but it cannot be reversed by putting the bulb in any position. When it is in the state of the highest sensitiveness, and the potential or frequency be varied, the sensitiveness is rapidly diminished. Changing either of these but little will generally stop the rotation. The sensitiveness is likewise affected by the variations of temperature. To attain great sensitiveness, it is necessary to have the small sphere S in the center of the globe L, as otherwise the electrostatic action of the glass of the globe will tend to stop the rotation. The sphere S should be small and of uniform thickness. Any dissymmetry, of course, has the effect to diminish the sensitiveness. The fact that the brush rotates in a definite direction in a permanent magnetic field seems to show that in alternating currents of very high frequency, the positive and negative impulses are not equal, but that one always preponderates over the other. Of course, this rotation in one direction may be due to the action of the two elements of the same current upon each other, or to the action of the field produced by one of the elements upon the other, as in a series motor, without necessarily one impulse being stronger than the other. The fact that the brush turns, as far as I could observe, in any position, would account for this theory. In such case, it would turn at any point of the earth's surface. But, on the other hand, it is then hard to explain why a permanent magnet should reverse the rotation, and one must assume the preponderance of impulses of one kind. As to the causes of the formation of the brush or stream, I think it is due to the electrostatic action of the globe and the dissymmetry of the parts. If the small bulb S and the globe L were perfect concentric spheres, and the glass throughout of the same thickness and quality, I think the brush would not form, as the tendency to pass would be equal on all sides. That the formation of the stream is due to an irregularity is apparent from the fact that it has the tendency to remain in one position, and rotation occurs most generally only when it is brought out of this position by electrostatic or magnetic influence. When in an extremely sensitive state, it rests in one position, and most curious experiments may be performed with it. For instance, the experimenter may, by selecting a proper position, approach the hand at a certain considerable distance to the bulb, and he may cause the brush to pass off by merely stiffening the muscles of the arm. When it begins to rotate slowly, and the hands are held at a proper distance, it is impossible to make even the slightest motion without producing a visible effect upon the brush. A metal plate connected to the other terminal of the coil affects it at a great distance, slowing down the rotation often to 1 turn a second. I am firmly convinced that such a brush, when we learn how to produce it properly, will provide a valuable aid in the investigation of the nature of the forces acting in an electrostatic or magnetic field. If there is any motion which is measurable going on in the space, such a brush ought to reveal it. It is, so to speak, a beam of light, frictionless, devoid of inertia. I think that it may find practical applications in telegraphy. With such a brush, it should be possible to send dispatches across the Atlantic, for instance, with any speed, since its sensitiveness may be so great that the slightest changes will affect it. If it were possible to make the stream more intense and very narrow, its deflections could be easily photographed. I have been interested to find whether there is a rotation of the stream itself, or whether there is simply a stress traveling around the bulb. For this purpose, I mounted a light mica fan so that its vanes were in the path of the brush. If the stream itself was rotating, the fan would be spun around. I could produce no distinct rotation of the fan, although I tried the experiment repeatedly. But as the fan exerted a noticeable influence on the stream, and the apparent rotation of the latter was, in this case, never quite satisfactory, the experiment did not appear to be conclusive. I have been unable to produce the phenomenon with the disruptive discharge coil, although every other form of these phenomena can be well produced by it. Many, in fact, much better than with coils operated from an alternator. It may be possible to produce the brush by impulses of one direction, or even by a steady potential, in which case it would be still more sensitive to magnetic influence. Figure 6 shows a practical application of the Tesla bulb. The bulb itself, as will be seen, is excited by means of a Tesla high-frequency alternator, which, in turn, is connected to the primary of a transformer. The secondary of the transformer is grounded at one end, while the other end of the transformer connects with the Tesla bulb. Dr. Tesla, in an interview, stated that the best way to use the bulb for such experiments is when the shaft of light is in the position as shown in figures 5 and 6, at rest, but in a state of equilibrium inconceivably delicate. This is fully described above in Dr. Tesla's lecture. The inventor states that in such a condition, the shaft of light is marvelously sensitive to magnetic disturbances. Dr. Tesla informs us that a toy permanent horseshoe magnet not longer than 1/2 inch and with its poles 1/8 inch apart could with ease throw the shaft of light out of its normal direction across the whole room. In our illustration, an electromagnet is shown a few inches away from light ray, and we can imagine a slot in a screen in such a way that normally no light falls through it. If, however, very faint radio-telegraphic impulses surge through the electromagnet, the light ray will immediately become displaced and will fall into the slot. Inasmuch as this shaft of light has no inertia, it will follow exactly the dot and dash impulses surging through the electromagnet, no matter how rapidly they take place. They can then either be read off by the eye or, if desired, can be registered upon a fast-moving film. This method will, of course, only be used where the transmission is made at high speed, and where it would be impossible for an operator at the receiving end to follow the dots and dashes with the eye. The method shown by us in Figure 6, of course, represents only one. Many others can undoubtedly be evolved to use the Tesla bulb to advantage. End of section 11.